to say is I wanted to change, but Miss Young was too lazy to put on a different shirt for this video.
True. I've actually been wearing this like sweatshirt since I woke up this morning, and it is like 6 o'clock at night. So,
Well, you know, I was gonna be all colorful for you, but now we're gonna just go on with whatever.
You know why? 'Cause they just like to get stuff done.
Yeah, let's do it. All right, let's talk about the relationship between two quantitative variables.
Hey, you know what that's called? Bivariate data.
Bicycle.
And do you know what it's called when you graph two quantitative variables on the same graph?
I'm assuming it says scatter plot because that's what it says on the screen.
Yeah, it's scatter plots, whatever. So when we graph bivariate quantitative data, we graph it on a scatter plot, which means we need to put something on the x-axis and something on the y-axis. Generally, the thing that we put on the x-axis is something. Are you putting something right now? Thank you. Thank you.
Something. Except I can't write.
Remember, we actually talked about this before. We in the comparison of independent variable and dependent variable, your explanatory would be your independent variable, and your response would be your dependent variable. And I hope you remember from science class, is it independent or dependent that goes on the x-axis, Mr. Bobby?
Gosh. Independent on the x, dependent on the y. That's like domain and range from algebra.
Right.
Why can't we all just agree to call x and y? But no, we don't.
No.
Okay? Just get over it. Learn the language of whatever it is you're going to do for your life.
So we put explanatory on the x, response on the y. So let's go back to this graph that we looked at before, median income in Arkansas since 2000. We already looked at it a little bit, but I will say here that we're saying, okay, the years in this case would be my explanatory variable, and the income or median income would be the response variable in this case. Okay.
And I always remember it. Explanatory's got the x in it.
Ooh, that's a good one.
Yeah, I kind of like have to remember things.
Yeah. So when we looked at all those other graphs, Mr. Bobby, what did we learn to help us describe? Because we want to always talk about certain characteristics.
Yeah, we wanted to, well, you had to do the whole cuss and BS thing before, right. But I don't see a center here.
Yeah, it's tough, right? I mean, we could talk about.
We talked about this graph when we talked about it before. We talked about some strange points, so that might be like the unusual ones. Like these guys down here were kind of weird. Let's see what else. Shape. Well, this isn't like bell curve or normal curve, but we talked. Maybe we could see like a pattern to the point.
Does it have a pattern? Yeah, that'd be a good shape.
What about spread? I don't know about spread. It doesn't work here.
Yeah. So we need a new one?
Yeah, it's probably going to be something that makes me uncomfortable.
So we're going to use Duff's. We're going to use Duff's.
I do like Homer Simpson.
I don't know if you guys watch Homer Simpson, but he often drinks a drink called Duff's. And that's what we're going to use to describe a scatter plot. Mr. Bobby doesn't like this, in case you wonder.
I'm petting my dog, so I'm getting a little dog snoopy. Hey guys, look, you want to see? Can you see that little face down there? That's Hamilton.
That's a new puppy. Well, he's 2 years old, but he's new to Mr. Bobby.
New to me.
Yeah.
And Hamilton comes out on Friday in like 3 days, so on Disney Plus. So I'm ready to go. All right, talk about Duff's.
Oh, okay. So we're gonna look at. Every time we look at a scatter plot, here's what we're looking at. What's the direction? Now, Mr. Bobby, when we say what's the direction, what are we talking about?
Well, we're talking about, like, is it going uphill or downhill? Okay. Yeah. Now, like in algebra class, we had a name for that. Like if it were a line, we called it slope, but we can't do that here. That's not cool. So,
why?
Because it's like different here. It's a different course. I mean, it's still the same thing.
It's the same.
Same. If the graph is increasing, did I do that wrong? Wait, no, other way. This way.
Whatever.
This way. Yeah, if the graph is going that away.
Yeah.
That's a positive association.
It's,
It means as the explanatory variable gets bigger, the response variable gets bigger. Hey, it's a positive slope.
yeah. You can call it slope. It's fine.
That's fine.
I'll take it. Negative association means, and guys, the explanatory variable is always getting bigger. It's what is the response to the explanatory variable that's getting smaller.
Now, the way the statisticians think of slope is a little different, and we're going to talk about that later on. Okay, they don't use slope in the traditional sense, but it is still slope.
Yeah.
We'll
so that's the thing that you need to tie it in. Now, when you're actually responding to a prompt about describing a scatter plot, please use the appropriate language for statistics, okay? All right, so now let's talk about unusual features.
And this is kind of equivalent to the outliers. Remember I said that I kind of had the shape and stuff, but oh gosh, the dog Blue is now getting into right.
So
and we had the same property before. We had clusters and influential points and outliers. And we already talked about this graph. We had those little points that were kind of out of whack in the 2000, early 2000s, late 20-aughts. 20-aughts and early 2010s or whatever.
So this is kind of like, first part is like, is it skewed, right? Is like, what's the direction it's going? And then the next part is like, is there anything weird on the graph? Do we have any outliers? Do we have any clusters? And then we're gonna go into form. Now, form is about that, like, is there a pattern in the graph? And if there is a pattern, we only care about two things. Is it linear or is it not?
You've heard the linear, Shakespeare line, to be or not to be?
Yeah, linear.
To line or to not line. That's it.
If it is not linear, there are whole other statistics classes later on for you. But for us, what we care about is it linear? Because if it's linear, we can do a lot of things with it. If it's not linear, we got a problem.
So, I mean, if the data looks like this or looks like this, or remember when I was like blobbing it?
Mm-hmm.
And I kind of can circle it in a blob that is roughly linear. But if I've got a graph that is bendy, like a parabola or wavy, I don't care. Don't tell me that it is a cubic function or that it appears to be a sine. We don't care. It's either a line or it ain't a line.
Yeah.
If it ain't a line, you don't have to tell me what it is.
And I know, like, you see a lot of exponential graphs, and there's a lot of stuff that people do using predictions with those graphs. That's not for us. It's not for us.
No line, you're done.
Okay. Now, we talk about direction. We talk about unusual features. We talk about form, linear, not linear. We probably need to talk about what does the strength of that form.
And a lot of times you get a and if you've ever seen any of this regression stuff or any of this modeling in a previous class, you have a very false understanding of this.
Yeah.
And they're not going to argue with you. You say moderate or weak. It's how, like, if I see a blob that looks like this and the points all fall in that's really strong for stats.
Yeah.
Okay.
In real life, there's so much variation in the data.
Yeah.
Even in what we consider like a strong correlation, there's just a lot of variation. So we're going to look at a weak one. But most of the stuff we look at will be moderate to strong. But if you are unsure, like if you're on the cusp of, like, it's kind of weak, but
it's like moderately strong, don't hedge your bet, pick one and go.
Right, just go with it.
Yeah, don't say don't ever combine these two of these three. It's not like a Chinese buffet where you can get a little bit of
I'd like a little strong.
You got to pick. Yeah, you can't mix General Tso's chicken with broccoli and rice or something. I don't know, but you can't. You got to have like one. Pick one and just go.
Yeah. Okay, so let's look at a couple of graphs. Y'all are gonna love this video. It's short too. Here is our median income back again. And so we're looking at this and we want to describe the distribution. Put this right here. There we go. We want to describe the distribution. So where do we start?
We have to do D for direction.
Mm-hmm. So we talked about this was a little confusing because it almost looks like it's decreasing and then increasing. But if we're going to just like back up, blur our eyes, overall, right, exactly right. That's what we think, right?
Did I circle every single point? No, I circled the majority of them, and I'm looking at a trend. And I'm going to address those other points later on.
Right. So yeah, I mean, we say there appears to be a positive correlation between median Arkansas income and years since 2000. And what did I do right here to assure myself that I have a solid response? I was specific.
Yep.
I talked about the variable.
Wishy-washy word.
And I used my wishy-washy word. Appears. All right, what comes next? After direction, we have
the U for unusual. Now I'm going to talk about those extra points down here. There's some points down here that I left off.
Yeah. Okay. So we got some like, I said between 2009. No.
Actually, I guess it's those.
Yeah. But really, like you can, if you went all the way up to 2015, I'd be like, cool, I see what you see.
Yeah.
Right? So I said there appears to be a cluster of points between 2009 and 2013. Here's where I want you to be careful. What is it about those points that makes them unusual? So it's not really enough to just say, hey, there's some weird points, but you need to say what about them makes them unusual. And so I said they're lower than what we would expect them to be.
And suppose, like, I think Mike Huckabee was governor in the early 2000s. Suppose Mike Huckabee decided to give everybody in the state of Arkansas $20,000, and there was 1 point up here for 1 year. He just like everybody in Arkansas gets $20,000 for that 1 year.
That'd be nice.
That'd be nice, but that's an outlier that appears to be it was significantly higher than the other.
Right.
Or appears to be higher than what is expected.
Right.
That didn't happen, but
it would have been nice.
It would have been nice. I'm going to mute for a second while you keep going, and I'll keep writing.
Okay. And then we looking at form next. And so remember, when we talk about form, we're saying, is it linear, is it not linear? Well, guys, you got to kind of blur your eyes out for this one. Ignore that cluster down there and say, can I say it's linear? Yeah, I mean, I could say that it's roughly linear. Is it like super linear? No, but it does appear to be roughly linear.
And I'm going to say I was guilty of this as an algebra teacher when I taught algebra 2. Actually, Miss Young and I were both guilty of this when we taught algebra 2. Didn't we do like an activity with Barbie dolls or something, or stuff like that? And if you've done that activity, boy, that data came out nice. Ooh, is it pretty? Mm-hmm. If you've done something where you measured your forearm and your overall height or something like that, ooh, that comes out pretty.
Yeah, looks perfect. Like just like dot 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 dot.
That ain't gonna happen in real life. Sorry.
So what about the strength here then? We got this cluster at the bottom. We got scatter.
It's moderately weak.
Oh dear.
Oh wait, no, I said not to do that.
Don't do that.
Pick one.
Yeah. So there's a weak and a linear association. I'm not going to say it's strong. If you said moderate, I'd take it. If you said moderate, I'd take it. If you said strong, I'd argue you.
Yeah, you can't you can probably get away with moderate for a lot of it. Yeah. I mean, unless it's like perfectly lined up, then you know, there are going to be some cases, but do not combine.
Now, one thing that you can combine, and it will not hurt my feelings, is if you put this in one sentence, there appears to be a weak positive linear correlation between median Arkansas income in years since 2000 with a cluster of points between 2009 to 2013 lower than we expect in one sentence. that's fine. Okay.
Really long sentence, but you got all those elements.
Right. I'm not saying you can't do that. I break it down like this so that you can try to remember that there are 4 things that you have to talk about. Okay.
You
got to mention direction. You got to mention unusual features. You've got to mention form, and you've got to mention strength. Okay. And you've got to be specific and mention the prompt. Okay. Let's do that one more time. So I went ahead out of curiosity and I grabbed California.
Don't ignore me, but I won't be ignored.
Whatever. California's income. Same years. Here's California. Here's California.
Oh, I didn't do a good job circling that.
It's confusing. This one's tough, right? Yeah. This one's tough. So I'm about to like make a point here of like just how confusing this can be when you're trying to read this. Because what if I circled these and said those were my cluster? That was my cluster back there.
Or what if I did this?
Yeah, the overall.
If I were going to do a blob.
Yeah.
Or I could do a blob like this.
I would
too much detail.
You've got too much happening there. Yeah. I would probably do this is what I would do. Yeah. Now, can you see what just happened here is my eyes saw something increasing. Mr. Bobby's eyes saw something decreasing.
But my glasses are probably thicker than hers, and I actually need these.
Yeah, I don't need these. I can take them off. So my point here being, there's going to be way more stuff we can pull from this, and we're going to. We're just doing this off visual inspection right now. So because I wrote this, we're going to go off of my blue circled cluster of points here, or group of points here, and we're going to write based off of those. Okay?
I think you're going to prove yourself wrong.
I might. You never know. So, direction. There appears to be a negative correlation. Wow! Just kidding. You know why Mr. Bobby circled the negative ones? Because he remembered what I wrote. Guys, yeah. And this, guys, this just goes to show you like how much our eyes can see something totally different from one time to the next. And that's why we need more, okay? I did that on purpose.
Sure you did.
I didn't. So if I were looking at this cluster, right? If I were looking at this, I could call it linear. If I were looking at, I could call it negative. If I were looking at the top points, I could call it positive, right? It does appear to be negative if I circled this cluster or this group of points right here, but there's a positive association right there, okay?
Yeah, so you can see the imperfections in this already.
Yes.
I hope so.
Yeah. Okay, so unusual features. We got clustering again in that same location. Or if we're looking at this association, we've got clustering up here, depending on what we're looking at, which would change my dates.
Yeah.
I said it would appear to be nonlinear. Like I'm looking at this and I see 2 distinct patterns. I see the first part of the data is decreasing and the second part's increasing. It really does look like a curve.
It does look like, I would, I might want to, I know you were tempted to name this purple graph.
Don't do it.
I know there's a word for that graph because I teach college algebra. I know what it is. Don't have to use it.
Yeah. And when I look at the association, when I look at the strength, because I can't make any decisions on it, I'm not just going to say it's weak. I'm going to say it's very weak. Like, I have no idea. And I said Arkansas. I copy and pasted it and changed the word. So let's make that California. Yeah, thank you. So smiley face. When you're looking at a graph, the stuff we're moving into is going to help us take these 4 things and break them down into a place where I have more information to pull from, and I can actually move forward with the data because I have more information to work from. Okay.
you, yeah, that vary adds nothing to it. You're not going to get more points for
No.
that. Okay? No. So again, you can put that there, but it's not going to add anything to it. And
Makes
the way we ended up circling it to get a negative might be 2015 to 2018.
Yeah.
Right?
Yeah. And when we decide, when we actually create the analysis and it tells us it's positive or negative, then we can start looking at, okay, if that's going to be the association, where's the clustering, right? So turns out, if we wipe all that stuff away, turns out that what we should be looking at is this top part of the graph, okay? This really is our trend. If I were to have given you before 2000, it would have fit in alignment with this part of the trend right here. And we would have clustering in the same spot as we did in Arkansas, and it would be very obvious.
And we know this because we lived through this and remember it, because we didn't get raises in that time period.
Right. I think, Jonathan, how long did you go without getting a raise at UAMS? It was like crazy.
Yeah, I know. My wife was with UALR at that time, and it was like 3 years in a row she didn't get any raises in the early 2010s.
So during that time period, they call it actually the Great Recession. And it is often compared to the Great Depression, where not only was there no growth, but everything fell. Markets fell. There were lots of crises. So if you have never heard of this recession and you're curious about it because you are interested in the economy and maybe what's going on right now, there's a link in here. And I would absolutely just take a little bit of time to go and see kind of what happened. It really kind of centered around a mortgage crisis. But
that's a debate over whose fault it was.
Yeah, but that's for another class.
And if we were able to actually extend the data, like the reason she's only got data for 2018 is it takes a while for the government to publish this kind of information. I suspect if we were to gather the data and look at it 3 or 4 years from now, we'll see another dip for 2020 for sure.
Yeah. Okay, that's it. You've got 4 Khan Academies. I think they're super duper easy. It won't take you any time at all. Thank you for joining us on this lovely evening, morning, afternoon, whatever time of the day it is that you're watching us.
Yep.
And can we talk about this glacier? Wouldn't you like to stand in front of this glacier at some point in Antarctica?
I haven't been to Antarctica, but I've been to glaciers before. I've been to glaciers.
One that big?
Maybe not that big, but boy, man, when you see ice falling, like the glaciers calving, they call it, man, that's pretty sweet. You need to see it.
Amazing. Okay. Bye, guys. Bye.